What we're going to talk today is about architecting the AI bridge, but before we really do that, we're going to start thinking. Actually, to be counterintuitive, close your eyes for a minute, and what we're going to do with here is I want you to picture yourself on a beach. The way I've been thinking about this one is I have small kids. I think of Moana. You think of the waves crashing, the sand between your toes. Life's good. The island has everything you need. There's a problem. You have stage 4 cancer. I'm awesome. I'm WebMD when you have the stomach pain. But in this situation, it's not going to be the WebMD case. It really is going to be the case where you are that person on a remote island. You are that person who is dealing with the situation of you have stage 4 cancer. It's not it's not a fun time in all honesty. But today's worse. Your temperature's gone up. You know something's wrong because, it's more wrong than usual. So what are you supposed to do? You're supposed to call your oncologist. And you know what's going to happen whenever you need that situation? You don't get an answer. So what next? Well, in those situations, what you typically do is you'll go and take the normal route. You'll say, in those situations, you're advised, go to the hospital. A lot of implementations of AI that you've seen will have, they put them out as a POC. Everything is done as the initial part of it, giving, what I've learned this week is since everything's off the same public data, you essentially will get the same answer from a different piece. So they put the button in, and within there, what's it going to tell you? Seek a hospital, call your 911, whatever your situation is. It will say not medical advice. I'm going to say that they prompted this to make it so it's medical advice. And this is fine. Like, you're on this island, you may have 45-minute wait, 2-hour wait. Not fun. My wife's immunocompromised. I look at all of these and it's a nightmare. And then it becomes a bigger nightmare. You have an emergency surge. What's happening? Every hospital is overrun with emergency room visits. There's no bed availability. Think back to 5 years ago during COVID. This was a very real reality. You have stage 4 cancer. You can't go to the hospital. This is a recommendation that if we made that same one again, it's going to tell you the same thing. And this is a problem because it's working with the data it has. It's statistically correct, but from there, it's situationally wrong. And that's ultimately that models by themselves can't keep up with fast-changing conditions. You have to retrain it, you have new data, you have new things that you need to deliver. With GenAI, ultimately everything comes to probability. This is statistical analysis. I have a weight that says this is what I should do in this situation, and then, like I said, from this week, a public model is going to say, based off this data, this is what you're supposed to do. Yes, you can do a ton of things that we are going to show, and that's when I hand it off to Alex on the next part.
Next slide.
You want this back?
Introduce ourselves. So, a little bit of our background. I'm Alex Porcelli. I'm working with Symbolic AI for the last 20 years. What is Symbolic AI? It's a different branch of AI that is basically deterministic. So the same inputs get the same outputs. You have rule engines that are famous for that. There are other types of symbolic AI, and we'll explore one of those today. That's DMN, which is the decision related. I've been working with this for about 15 years. One of the most famous and used rule engines and decision engines in the world is Drools. I've been involved with this for about 20 years. I'm BPMC member. Drools is part of the Apache Foundation. And that's my background.
Yeah, and I'm Tim Wuthenow. I'm a co-founder with Alex of Aletyx. I've worked in the business rule space for 15 years. And for me, this is one of those things that what we get with this is that there is so much of the two areas that work really well together that we're going to show today, because The deterministic point of view is very important, but so is also the unstructured data that you deal with in everyday situations, and that's what we're going to show today.
Yeah, and as mentioned, LLMs are fantastic for the interaction. They understand the complex inputs, and they are able to transform that in a format that is computable, readable. So these transformations is very powerful that it's able to do. Everyone is doing this at some extent with the MCP protocol, and we'll show exactly we're not different here. We're taking the same path. But the thing is, the LLMs are based on static data. They were trained before. And we've also learned over these 2 days of the conference, we have what? You need to provide context. You need to provide more context so they will give you better answers. But what's interesting is not only the context may not be enough, because in this case, we don't need only the context, but we need a magical procedure or whatever reasoning that you want to have behind the scenes. And that's where we are bringing the symbolic AI part. Because symbolic AI means that you ensure the deterministic behavior. And that is critical in certain scenarios. And of course, we are using here a little bit of extreme scenario on the healthcare system. But think about your core business systems. We are talking about the AI all the week, like all the time and for the few years. But it's very hard to get AI integrated or infused in your core business. It's all around, but it's hard to get in the core. Why it's hard? Because it's not deterministic. It's part of the business to always have similar or the same outcomes. It's contract-based, B2B, B2C. You need to follow some type of rules. And that's what we are heading here. It's like combine these things. I remember, I've been working this for many, many years. About 10 years ago, we were trying to integrate natural language processing with Drools. It was great ideas that we had, but it was so expensive, the research for that, or the infrastructure that we need to put together. And I remember when ChatGPT came out, I said, that's it. So the infrastructure is now available and quite cheap compared to what we found that way. And create these bridges is like, for someone that have been working on the decision space for that long, is a dream. You see the other technologies that try to mimic natural language processing, but this is real NLP in your hands, at some extent. And again, we are advocate here is not one technology or another technology, it's the combination of both. Because with a hybrid, you can get the rich interaction that you have with LLMs, you have the deterministic behavior, and you are able to transform the context from the LLM to the hybrid, to the symbolic AI, and coming back and forth. So giving the users a very rich experience. And as a result, you have a robust but important auditable AI. Because you have a deterministic behavior, and one of the characteristics that you have in the symbolic AI is that it's audible. You can replay the thing. So it is something that is business friendly. In a world when you have regulations, for instance, many industries are regulated, financial, healthcare, and insurance, for instance. You need to replay, you need to show the regulator how the things operate. And this approach, you get that. So, how we achieve that? MCP. The week we're seeing, the few days we are seeing a lot of MCPs, and we are not different. The idea is you are able to have a system in here that is MCP server, which is basically a Spring Boot application that serves that DMN models, or that we'll see in a second what DMN means. And this, it will interact through the MCP with the LLMs. And the interaction will go back and forth between them. We have a specific catalog of the decisions that are available, and this is where the LLM is able to understand what to ask, because we also provide, as part of the MCP protocol, which everyone showed so far, the inputs and outputs of each decision.
So in the interactions that you have with the user, if some data is missing, the LLM will be able to ask the additional information. And this turns in a very rich experience. So we are talking about DMN decisions, what it looks like. This is more or less what it looks like. But step back, what DMN is. First thing, we are in the open source ecosystem. This is an open specification, it's an open standard. That's also one fundamental aspect of the DMN. It's a standard. So you have different vendors that provide different runtimes, and that's fine. We, as I mentioned before, Drools is one of these runtimes, which is open source and Apache Foundation. What's interesting about DMN specifically? It was designed not only for developers. Well, it's a developer friendly. You have a language or expressional language there. But it's also familiar for non-developers or business analysts or anyone that interacts with the business, not necessarily only developers. It has graphical visualization. The decisions you see, there's the circles here are input, and each square are basically the decision that you made. In this case here, you see that you have one input, you have an intermediate decision, and you have the final decision on top. That's basically how it works. And majority of the time, when you're making decisions, the decision format that you use is a decision table. Think about a spreadsheet that you have conditions by the columns. Oops. You have decisions by the columns, and you can have the expected outcome. And the decision engine is able to do the match. What is interesting about the DMN is because it is human readable, it's friendly to non-developers and developers, anyone that has familiarity with spreadsheets formulas, they can write some expressions for here. And this is also executable. So you have best of both worlds. And again, it's an open standard.
And actually, there's one more part of this that's important that isn't talked about on here, is it's also self-documented, but also you can add further documentation to it, which is where this fits in more with the large language model usage that we'll get into, because now you have that explanation of your decision tied to that. So one other thing just to look at it is the boxes are questions that you're answering. So you ask a question, you get an answer, and that's what the goal is at the end, get to your final answer. Much like an LLM, what is my answer to this question?
Yeah, great input. And again, what's interesting about being an open standard is that LLMs are trained already with this. And they are able to explain what that particular decisions are doing behind the scenes. And in my perspective, as being, again, working with rule engines for a long time, this provides a real good level of abstraction. Because here, you're just having expressions and decisions that are focused on the business. When you're using rule engines, they are a little bit mixed with code in general, and that code may have mixed with infrastructure. So it's hard to extract just the business aspect. And in this case, you have a very explicit, isolated business rules defined in here. So I think it's very powerful. And again, it's a standard, it's understood by LLMs. We could try, well, have a long demo, but you can get to this. Behind the scenes is the XML file. You drop it to LLM, explain this to me, and this will be able to explain what that decision means. Very powerful experience. So some characteristics, again, open standard, it's executable, business friendly. And when you're talking about the LLM integration through the MCP protocol, it have instant adaptation. And this is very powerful because you go make a change in your decision and is automatically available to the LLMs. So in cases, let's get back to like e-commerce general, think more close to daily routine. You have like Black Friday. You can change, like you could change the policy for the pricing right now, like at 11 p.m., and it will be able to be reflected because again, it is it's instant adaptation. And again, everything is transparent and traceable. This is very important in regulated industries. And it's very developer friendly. We can show, like, can you take a look quickly on what it's look like an application? So this is a regular Spring Boot application. Oops. Just a Spring Boot, and you have the DMN file as part of resources. And as a dependency, of course, we have to have Drools. That's the technology that processes that, the engine. But it's just a project that you run as a Spring Boot, Maven clean Spring Boot run, and you have it available, that services. In this case, we have the MCP available here. But you have also, for regular use, you have REST endpoints, Java APIs, native APIs.
Yeah, and just to extend it, using Spring Boot, you get the benefit of like connecting it to Claude, using the local server at the bottom. It would just be, I changed the port to being some random one, but the 34115/SSE point, that's what we're using within this. And then if I add more DMN to this model or to this application, then those become available for that application.
Are you able to open the Claude?
The actual risky part of a demo using Claude Desktop?
Yeah. Claude Desktop is always fun.
So I can either do it this way or we can ask it differently. How do you want to go?
The safer?
So I'll just ask first, what decision policies do you have connected? This will ultimately tell us, first off, am I able to get to the catalog? So, and this is the one that you always pause on because you're like, oh my God, is it going to work? Because Claude Desktop, it updates every day, it feels like. So you'll get a crazy policy name because that's what was auto-generated from it. But it's saying I have a local decision policy tied to it. And says you can go into details about the policy. So what you can then do is, what types of inputs do I need? Come on. No, I guess enter is not going to work for this. So what types of inputs do I need? Basically just continuing it, understanding what it's going to do is it reads the input schema. What's nice about this is that from that standard, you're getting the inputs and the outputs for it. So from a longtime decision practitioner, the worst part was always putting together the final thing to make your rules work. You could have these complex data objects of hundreds of thousands of things thrown into it or weird variable names. Now I can just write a scenario. So like in this case, it's going to tell me, oh, this one it's also tying to my, my remote policy. So I'll make it bigger so you're not seeing my messy desktop. But I can see, like, is it a cancer patient? Is it a hospital available? Is there a heart attack involved? But also on the other one, it would tie in there. So I could ask the case, so using that same example from before, I have stage 4 cancer, and I might have to put this as a demo. This is a demo because, okay, no, I don't want to answer this. But, and there are no hospital beds available. What should I do? And in this case, if we're going to find out if the policy I didn't erase it beforehand. What it'll do, it's going to call that DMN. So it's going to start figuring out, like, I have a cancer patient, I base it off the schema, I'm mapping it to there. I just said that there's nothing available. So you take that same situation we had before. We saw that there's no hospital beds available, and then it'll execute it. And this is where Claude is always fun. Is it going to work on this one? Which it's not, because it's going to stop for right now. But my demo.
Yeah, we'll go back to that part.
We'll get there.
Claude Desktop is always unstable. Anyway, the idea is to show that it's a very developer-friendly technology. You run these as a Java application, just drop, in this case, in your resources folder, a DMN. Of course, you have to have the Drools engine or any engine that process, and you're able to get advantage of that. I think how basically the idea for Bridge works is you get the natural language processing from the LLMs, and the MCP gives the visibility on the catalog of the decisions that are available, the inputs and outputs of each decision, and how to execute that decision. So we provided 4 tools through the MCP protocol, and this is enough to be visible to the LLMs to execute. If anything is needed, back and forth to the user. And when you are building real system, you have integration also with real-time orchestration of different environments. As we mentioned before, and especially in the scenario of the healthcare system, is not only data that you have input, but you want to collect the information from different systems, like what's the waiting time of the hospitals in this case. And you get it all together and process, get back to the user. And I think we'll go back to the system, the healthcare system, and we'll now see how we could solve.
Okay. So going back to this, and we started seeing it with Claude Desktop, but we're going to pretend we haven't yet. But what we can ultimately do is we can build a better way, as we were told. So we know right now this situation is there's diversion, there's other pieces going on that basically says you're in a bad situation. What we can do, and I'm going to show this part first, and then I'm going to do a different scenario because I want to just explain the magic before the magic, is that what we can do is when we call this decision, what we're going to have here is it makes it smaller, but what we're able to take in here is where my decision ultimately fired is I made a carefully crafted piece that you're going to be called by Dr. Know-It-All, and that's what's ultimately going to go on. The reason that this one is occurring is because there is within, so when mentioning like DMN's open standard, Drools is open source. Part of this is also from Clinical Pathways. Clinical Pathways were a part of an open group that's now used to be in the object management group, now is in HL7, where it was BPM plus. And there were these calls that I got to sit on with lots of doctors that had way more degrees than I'll ever know. And I would just absorb and be able to know some things. That's why I went with Dr. Know-It-All, because it was fun. But ultimately, what you can do here is what would happen in these situations is what we mentioned before is that the models themselves are public information. They're taking the public data for what you have. This is, assume this is the hospital system. Well, somebody in there has the knowledge. What we can do is we can, and I don't want to use that one because that one won't have the stored model. What I can do from here is I can take this model, and right now I am going to delete phone number because that's less interesting. But I can take a recommendation. So what we saw before is that, and I'm going to try to zoom in because I know it's smaller in a demo. Were they a cancer patient? How many hospital beds are available? And this is what we're going to do. Now, this isn't something that you would give to just anybody in the hospital. You're looking at somebody who is an expert in this, somebody who has, for lack of better words, the ability to control the decisions that are made. The ones who basically have the industry know-how or the knowledge of your enterprise versus the statistical models. You're taking your policies and injecting them in. So let's take a different situation because we have a different one, is if we go to the hospital demo and we can choose a different patient. So let's instead do a stroke patient because I'm guessing I'm just sadistic. And ultimately on this, so this would be like a 68-year-old who had a stroke, so once again, not a good situation. You're near certain pieces. If I ask it as it is, once again, would you do all this in real time in the same way? Maybe, maybe not. But in this case, it's going to say, call your primary care provider at 91922, whatever number. Not helpful in this particular case. Or somebody realized that this wasn't what we want to do. And why is that? Because this is our default case. If there's less than 2 beds, we tell you to call your primary doctor. Now, the phone number was in there because I was going to do something cool with the phone number, but I didn't want to do that. But what we can do is now say, what we don't, in this situation, we don't want stroke patients. going to the hospital. And we know that this is, in this case, we're going to set this as a Boolean because it's a true or false. You had a stroke or you didn't in this case. And what we're doing is I'm going to add one here. Now I'm adding it in the middle because, and this would be something if we want to go into much more detail about DMN, we can. You'll see an F up here. It just means first. So it means whichever rule hits first in this, as you're evaluating, it's going to hit the first one. So if you do it after go to ER, it's always going to recommend ER. So we're not going to do that. But what we're going to do is not that one. I'll edit here. And I can change the input from what it is to had a stroke, Boolean, enter, and then just say true. And in this case, it doesn't matter. We're going, and this is where you get an ambulance has been called, because there are other systems that can work in the background on this that you can trigger from here. An ambulance has been called, will be dispatched shortly and arranged to a different hospital. Because in a stroke, as with most things, time is of the essence. So if I go ahead and deploy this, and what this will do is it's now live. I could go back to my demo, rerun this same situation one more time. It's going to analyze it, and now my model knows that an ambulance has been dispatched. What would also be triggered in this is that you could trigger workflows and other pieces from this. This is definitely a very targeted piece of just saying one part of this. But ultimately, what we're seeing here, though, is that I can make my model smarter with my business intelligence, or in this case, my fake medical intelligence. I play a doctor on stage. And from there, be able to actually inject that to my model to make it have my business value for it. And then, like Alex was saying, we went really extreme with this because that's what it makes more sense when you're looking at it in the context of a situation like this. But this kind of situation happens in business. There's all kinds of, you observe that your recommendation model is running rampant. And why is that? Because you put the wrong price on your product and you see that you're tracking it. And how do you fix that? You could fix it with this. One of the benefits to, why did rule engines come out when they did? Ultimately, it was separating the application logic from the business rule logic. You can make faster changes. Now you can make faster changes that are smarter. I didn't do anything for my thing other than I have my patient and it didn't know that data. If we go into the trace events, it realized that the schema changed. So it says that I had stroke is now a new condition. I didn't tell it anything from that. If we would have looked at this before, it would have just had the heart attack. It's finding the data that I need, and it's able to contextually analyze that and then use that for my decision. And then my decision is used, and then we have the full context delivered to our end customer. And hopefully an ambulance gets there when they need it, and they go.
We are running a little bit over,
Yep.
I think.
Yep. And so,
Yeah. If you have any key takeaways, so we believe that hybrid AI is the future. You are able to reach different capabilities on the AI field, symbolic and statistical models. DMN is an open standard, very powerful technology, and build then you can have great outcomes. We may not have time to questions, but we have here, if you want to schedule a call that we can have a conversation, talk about the hybrid AI, we are happy to engage. And I'm not sure if you have time for questions. I think we are over a little bit, but thank you again, everyone, for coming. Hope you enjoyed. Thank you.